Okay, so I don't fancy writing all the maths again, so I'm going to record the audio on this as a post-commentary. So I'm going to watch the video and I'm going to talk. And hopefully, well, I should be able to describe it the same way. So, in this video I'm going to go through question 4, 5, 6 and 8 from the homework. This is question 4. I think here I'm explaining that I'm doing the questions for the first time, so you can see how my brain processes through them. And I'm taking my time to tell you that. Here we go. So reading the question, we've been given an equation of a circle where we can find the centre and we can find the length of the radius quite easily. The centre is 2 minus 5. Am I going to write that? There we go. So the centre is 2 minus 5, and we know the radius is 5. The fact that it tells us that point P, which we don't know the full coordinates of, tells me that it lies inside the circle. And also, it tells me that I want to find a set of possible values, so that's screaming inequality when I want to find a set of possible values. And the fact that it lies inside the circle, I can see that, well, if I find the length C to P, centre to P, that must be less than the length of the radius, because the radius goes from the centre to the edge. So if it lies within the circle, it must be less than the radius, because if it was equal to the radius, it would be on the edge, and if it was more than the radius, it would be outside of the circle. So let's find the length C to P. And we're going to find that algebraically because we have a letter as our y-coordinate for P. So I'm going to do point P subtract point C to find my distant differences, so 6 minus 2 squared, and K minus 5 squared. So that's 4 squared plus K plus 5 all squared. And that's all square rooted as well, because we're doing Pythagoras to find the length. And this is less than the radius, which is 5. Root 25. So now I've got 4 squared plus K plus 5 squared equals to is less than 25. I've squared both sides to get rid of the square root sign. Now I have expanded the brackets, and I have a 25 on both sides, so they will cancel. I'm left with a quadratic inequality of k squared plus 10k plus 16 is less than 0. So if I go to factorise that, it will be k plus 2 and k plus 8. So therefore, I'll have some provisional solutions of minus 2 and minus 8. They aren't my final answers, that's just helping me draw this quadratic graph, where I cross through minus 8 and I cross through minus 2. And our y-axis crosses 16, which isn't important. Because we're less than 0, then it's the part that is below the x-axis in the graph. So therefore it's bound between minus 8 and minus 2, and that's what our inequality should look like. Okay, question 5. Question 5 is a bit of a tricky one. It took me a bit to have a look at it and to really draw it to see what was happening. But something I knew that was going to be useful is the fact that a tangent, and where a radius and a tangent meet, that forms a right angle. And we've been given some lengths for them, and we've also been given half of a coordinate for Q. Well, I can form a right angled triangle, which is what I'm doing with that dotted line, where my shorter lengths are 6 root 5 and 4. Well, I can find the hypotenuse of that by just doing some Pythagoras. And I'm calling that length x. Well, that simplifies, well, doesn't simplify, sorry, that just expands to 196 when we do that left side, and that's x squared. So therefore I know x is 14. I can form a second right angle triangle just using the coordinates of the centre. And this is a bit of a key one. This is one that we might not have spotted. So I can form this blue right angle triangle now. And I know I've got my length 14. I know I have a length 11 because that's my x coordinate and I'm moving from the origin. And I know my height is of length k because my y coordinate in the centre is k. So therefore if I do root 14 squared minus 11 squared, that will just give me that length of k. So that gets me root 75. And it's not asked for it in its simplest form, so you could leave it like that, but we could leave it as 5 root 3. And then I think I go on in here and say, well, this is part A to a question in a test, so most likely part B would be to find the actual equation. It would be a nice 1 marker afterwards. And all we would do here is substitute our value of k, maybe a 2 marker actually, our value of k into the centre and then back into the equation of a circle formula. Okay, question 6. So the circle C, well, I'm not going to read it out, you can pause and read it if you want to. So let's see what I'm doing here. I'm drawing a diagram, I assume. Yeah. So this is a question that is quite difficult to understand, but once we draw a diagram, it becomes so much easier. So let's see how this simplifies the question. I've got my centre. I've got a point minus 9, 8. It's further to the left and it's further up. That doesn't need to be so accurate, but in the right direction helps. And we are given a point R, which is also on the edge of the circle. You could have drawn it anywhere. I just chose it to draw up there. We know the radius is 15. So these 2 dotted lines I'm drawing are length 15. We're also told that the chord from P to R is a length of 20. So we can see here I've got an isosceles triangle. And what we're wanting to find is the shortest distance from the centre to that chord. The shortest distance from that centre to a chord, shortest distance from anything to anything, is the perpendicular distance between them. So I've drawn that perpendicular line in the middle of my isosceles triangle in my diagram, and it forms a right angle. And when we draw a perpendicular line down the middle of an isosceles triangle, it bisects that bottom line. So that's a length of 10 now. And also a length of 10 on the other side. So if you just see half of that isosceles triangle, which I'm outlining now, you can see that's a right angle triangle. And we're wanting to find that perpendicular length, which is turning out to be the height of this right angle triangle. So it is just a case of some simple Pythagoras. 15 squared minus 10 squared, all square rooted. That's going to give me 225 subtract 100 root 125. Yep. And then 5 root 5. So a difficult looking question with a diagram turned into just Pythagoras. I wonder what I'm talking about now. Probably something boring. Oh, come on. I think I'm making that point that we have done Pythagoras for the last 2 and no actual circle, really big circle knowledge. And then let's have a look at this last one. So this last one caused us a bit of a bother. It looks horrible. Again, draw the diagram, draw the information on. It's always going to be useful in a circles question. So I've drawn in the centre from the equation. We know we have a radius 5 as well because we have equal 25. And I think I made a point there that it made sense because if you look at the centre and where it crosses the y-axis, that's a length of 5 and that's also the radius. I've drawn that point on that they've told me, and then I'm drawing the tangent to the circle. There's two possible tangents, and you should know with your circle theorems that either way that goes, they are the same length where it touches. So it does form an isosceles sort of triangle if we were to complete it. So T could have two possible points. We don't really care where T is, to be honest. We just want to find the length. And either of them T's will find the same length from point P, which is 8 minus 7. I think I'm referencing there the fact that from a radius to a tangent makes a right angle. So I've drawn that on there. We know my radius is 5, so I can label that length up as 5. Well, I need a third length to be able to go ahead and do Pythagoras. But if we see that dotted line I am drawing, we actually have the coordinates for the 2 points that make that line. So I can find the distance between minus 5, 9 and 8 minus 7 using Pythagoras to find that length. So I'm just going to go ahead and do that, the mathematics behind all of that. So the difference between minus 5 and 8 is 13, and the difference between 9 and minus 7 is 16. So 13 squared plus 16 squared, all square rooted. I think that gives me root 17 if I remember. Nope. Miles off. There we go, 5 root 17. I thought I remembered it. So that's a length of 5 root 17. Well, we're wanting to find the length from P to T. And then it's just a Pythagoras job. I'm going to draw the triangle out one more time. And it's just a job of 5 root 17 all squared, subtract 5 squared, all square rooted. And let's see what that gets me. I think I'm making a point that I know that that's going to turn to 425, so then subtract 25. And then that gets me to 20, which is my final answer. And that's it. I think I just make some point about the fact that we have done Pythagoras in 3 out of 4 of these questions. And it wasn't obvious that we needed to do that until we drew a diagram. But once we started drawing a diagram, it turned a lot more obvious. So that's it from me. Hopefully the post-com was just as good.